for example 2, I'm going to be composing f of g and then g of f, and then I'm going to find the domain of each. The domain of a composite function is the domain of your new function that you have created, including any domain restrictions of the inner function all by itself. So you compose your function first, then you find the domain of your new function, and then you separately look at the domain of the inner function and include any domain restrictions for that. And the intersection between the domain of the composed function and the domain of the inner function is going to be your complete domain for the whole problem, for the whole composition. So let's first compose f of g of x. And f of g of x can be written as f of g of x like that, with a little g of x inside. And I'm going to set up my f function ready to sub g into. F is the square root of x, so I write down the square root and put parentheses in for my x. And then into that x, I'm going to now substitute in g, which is x minus 3. And then to clean that up, I'm just going to remove my parentheses. In this problem, they really weren't necessary, but I still like to put parentheses in for every x, no matter what problem I do, and I just take them away if I don't need them. And that is just f of g of x. Now the first thing you're going to do is you're going to look at your newly composed function, and then you're going to find the domain of that new function. I know that underneath my radical, my even radical or even root, that cannot be negative. So negative numbers are less than 0, so I want to figure out where x minus 3 is going to be greater than or equal to 0. And then I'm going to solve that equation or inequality and add 3 to both sides, and I get x has to be greater than or equal to 3 to make this positive. Now I need to look at the domain of just the inner function, and in this problem it is g of x. The domain of g of x is simply all real numbers, so there's no other domain restrictions that are going to tag along into the domain of the composed function. So my final answer for the domain of f of g of x, or just f of g, is equal to 3 to infinity. Anything greater than or equal to 3. And if a number line helps you to write your interval notation, then it would look like this. I would have a closed circle at 3, and anything greater than 3 is to the right, and there you have it. Okay, so let's go ahead and do g of f now. First we did f of g, now we're going to do g of f. So g of f of x can be written like this: g of f of x, with the f of x inside the parentheses. And I'm going to get my g function ready to plug in whatever f of x was for all of its x's. And g of x is x minus 3. And inside that, where that x used to be, I'm now going to put f of x, and f of x is the square root of x. And I don't need the parentheses, and when you're composing your function, you didn't really need to put them in anyway, but for all of my problems, wherever there is an x, and if I need to sub inside it, then I'm going to put the parentheses there because that's how I like to do it. So since they're not needed, I'm going to remove them, and then that is my g of f of x. Now we're going to figure out the domain of g of f of x. And this isn't going to be that interesting, but the technique is still going to be the same, and so I'm going to go through the motions and do this in detail. The first thing I want to do is find the domain of my newly composed function. So as I inspect it, I see I have a square root, and I know that underneath that even square root, or that even root, my radicand underneath has to be positive. And so positive numbers are going to be greater than or equal to 0. I should say it has to be non-negative. And that means if it's non-negative that it has to be greater than or equal to 0. so positive or 0. So I'm going to take my x, set it greater than or equal to 0, and it's already solved. There's like nothing to do. So I know that, sorry, there's a cat. All right, so I know that the domain of my composite function is greater than 0, and I'll draw the number line. And it looks like this. And now I just have to find any additional domain restrictions from my inner function f of x. So I'm going to go ahead and look at f of x, and I see that my inner function is the square root of x, and it has an even root, and I need to take that and set that equal to 0. So the radicand underneath is just x is greater than or equal to 0. And it's pretty much the same domain as the composite function. It does have a domain restriction, but the domain restriction is exactly the same. So the domain of my composite function is x has to be greater than or equal to 0. And when I look at just f of x all by itself, his domain separately is exactly the same. The x's have to be greater than or equal to 0. So the domain of my entire function of g of f of x goes from 0 to infinity. And I just saw I don't really like the way that I have an equal sign there. I would probably prefer to have a colon. Not that it matters that much, but there you have it. And these two problems are not that interesting because there were no extra domain restrictions from the inner function that affected the overall domain. So in the next example, I do have some additional domain restrictions that are going to be involved from that inner function, and you'll see how to do it then. Before I complete this video, I just want to tell you why we need to include any domain restrictions from our inner functions if you're not really sure about why we do that. And so I'm just going to give you a concrete example over here on the right side. If I were to say, let's find g of f of 4, and you were to do a little xy table, and you put in a 4 for your composite function, then first you would really be substituting that 4 into f, and then that would look like the square root of 4, which is 2. And then you would take that 2 and substitute it in for g. So then we would do g of 2, and g of 2 would be 2 minus 3, which is negative 1, and that would work perfectly. But if I were to pick another value for g of f, let me just erase this whole thing here. Let's say I chose a negative 2. Then when I try to first substitute my negative 2 in for f, then that's going to fail. And it's not going to work because I can't have negatives calculate underneath a square root symbol. So I can't even go any further. I can't calculate this value out in order to even sub it in for g. It would be g of like nothing because there's nothing to carry over. You don't get past that first step. So when you are finding the domain of your composite function, it has to work for the inner function first. And so you find the domain of the entire newly composed function and then include any original domain restrictions on the inner one. Sometimes when you build your new function and you clean it up, bad things go away and you lose the original domain restrictions that are in that were in your inner function. They cancel out, or terms get combined, or fractions disappear when you're cleaning things up, and you just don't get to see those original domain restrictions. So that is why we find the domain of our new composed function and then make sure we include any domain restrictions from the inner function as well.